Hello guys, here Gabby again. Today we are going to talk about a little bit about microservices and monolith, the real trade-off between them uh, in production, in developing, but mostly in production. So I hope this, but my experience could help you clarify something. So we could say that microservices are better. Um, that's one of the most dangerous oversimplifications in software that we could say, right? Because the truth is that microservices do not remove complexity, they move the complexity, okay? And if we do not understand the trade-off, we are going to build a system that is expensive, it's fragile, and it's hard to operate. Okay, so in this video I will break down the monolith and versus microservices in a practical way. What each one really is, which are the real pros and cons, and when we are going to choose one over another, and how we can apply the microservices in our project or monolith, but mostly microservices behind our application gateway. Okay, so um, there is a key rule, okay, that we must follow or have into consideration, right? And that's it. That is if our platform is not mature, uh, and we do not know exactly what we are doing, we are going to be punished. Okay, the microservice will punish you if you do not know what your business is, what you are trying to do. It's going to cost you a lot. Okay, so you have to be very careful with that. All right, so we have to get in a little context of what we are doing here. Okay, so what a monolith really is, we could say. A monolith is an application deployed as a single unit, okay? One build, one deploy, one runtime. Everything is there. Everything is there. One single unit of uh, responsibility. One single application. One system, right? Internally, it can be well modularized, okay, but deployment is still one piece and it often shares one database or a central scheme. You could have multiple databases, but you could also think about one internal database, um, and you have pros and cons, right? So which are the real pros of a monolith and the cons? The operational simplicity, one deploy, one log stream, one system. There is all centralized and modularized, and you there could have all you want. We have easier transactional consistency. One database, one transaction, it's all there. We have local debugging and troubleshooting are more straightforward because you don't have to go there, here, one microservice, see what's going on, and so on. Wow. Lower infrastructure overhead, no service discovery, no mandatory gateway, and fewer moving parts. Okay? Which are the real cons or contradictions or cons of having a monolith, we could say? Okay? As it grows, when it grows, we have long builds, painful merges, and harder ownership. Okay? Coupled scaling, we scale everything even if we only if we only have one part that needs it, is slow and with risky deploys. A small change requires redeploying everything. It's harder to understand if strong modularity is missing, and so on. A monolith can be great, okay? A monolith can be great, but it must stay modular or it's going to become a real mess. Okay? So, on the other hand, what microservices really are, okay? Microservices are a set of small services independently deployable, okay, aligned to the business capabilities. That's why I said before, you need to know your business. You need to know what you are working on, okay? You need to know what are your bounded context, what are you working on. If you have a payment system, you need to know your users, your parameters, your payments, and your adapters, and so on. And each service could have its own database, its own deployment, and typically it owns database or at least data ownership, right? The real pros of microservices are that they have an independent deploy, okay? Changes in one service A does not redeploy the service B. We have independent scaling, scale only what is hot under load, nothing more, okay? Ownership by team or domain, we have clear boundaries. With this, what I try to say is we could have a lot of microservices that are independently and they communicate um, in their own way, and we could have multiple teams specified in each microservice. Okay, we have clear boundaries. I am from team A. I work in microservice 1, 2, and 3. There are better tolerance for tech changes if needed. We can change mostly the technology or libraries in one microservice and not in another for certain things like technical details from the infrastructure without impacting the whole system. Now the real part, okay? What are the cons of the microservices, okay? So, what we could have here is distributed complexity, okay? We could have network latency, partial failures, retries and timeouts, tracing and debugging across microservices, because you could have n microservices and they communicate all together. And then suddenly is a bug, is an error, is an exception, you couldn't log it, is in production, and where is in microservice? Is in microservice A, B, C, D, external providers? Where is it? How can you replicate? So that is complicated, and have a good observability, telemetry, logging, and tracing is very, very important, and also an excellent error handling mechanism for all the sites. Okay. The consistency becomes harder here because it's no longer one transaction for everything. The transaction of something could require previously communicate with other external providers or other microservices. And also, well, the observability becomes mandatory. Traces, metrics, and correlated logs. Operations and CI/CD become much more demanding because they are many services. Microservices are not hard per se because of the code. They are hard because they are really distributed systems, and that's the most important thing. Okay? And we expose all of this through or behind the application gateway, the API gateway, the APIM. And what we gain here, we could redeploy changes in one service without touching the others. We could scale hot services like payments without scaling the entire platform. we separate ownership by models and domain. Here we have real DDD bounded context, okay? This is the core reason microservices work. Boundaries are aligned with business capabilities and ownership. You need to have a core business that is well defined, that you know what you are doing, and you can separate all the necessities as you want. Okay. When we would choose monolith over microservice, um, uh, when the product is starting and we need speed and simplicity, something fast, need ASAP. Okay. When the domain is not clear yet, the bounded contexts are immature, when the team is small and the operational cost of microservices does not pay off, when we need many consistent end-to-end transactions, and if I choose a monolith, I would build as a modular monolith, well separated internally. Okay, so we can extract services later when the boundaries become real. Okay, so when we would choose microservices, when we have clear domains and teams with ownership. We will repeat that we are going to use microservices when we have clear boundaries about the business rules and what we want, when we will need frequent changes and deploys without impacting the entire system, when we need scale per component, because it would not be the same scale a microservice of a payment microservice and a parameters microservice, for example. Okay, microservices are not a starting point, they are an outcome of maturity, which is the key difference, the product complexity and the platform complexity. This is the biggest takeaway. Okay, microservices do not remove complexity, they shift it. They simplify ownership and deploy per domain, but they add platform complexity, networking, observability, resiliency, and security. Okay, so the question is not microservices or monolith. The question is my platform ready to carry distributed complexity? So here we could apply, well, which are the best practices that actually matters in microservices. Okay, these are not optional. These are survival rules. Okay, so data ownership per service, not shared databases by hand. The services are stateless as possible. We have a clear versioned contract. We have resiliency, okay? Timeouts, retries, circuit breakers, we about cascades. We have observability with correlated logs, metrics, and traces. We have an standardized CI/CD. We depend on our infrastructure team, the operation DevOps. CI, CD, build, deploy, test, quality, security per service, and so on. And we also need the API gateway, the APIM from cross-cutting boundaries and policies across all the system. Okay, so what's the biggest risk in microservices? Distributed complexity, partial failures, and traceability. That's why observability and resiliency are mandatory. I repeat, as I said before, we need to keep in hand and all the things that are 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 traceable. All the requests, all the petitions, all the things that are not data sensitive, for example, so then we can track what's going on. Okay, if I have a parcel failure and I use a cancellation token, or I have a poly and something not working, the communication between microservices failing, we need to know what's going on. We need to have a trace. Hey, I have this request from microservice A to N. What's going on here, okay? Do microservices always scale better? Depends, not always. They scale better when we need to scale parts, okay? We have microservices. The microservices all together makes a system. Each microservices can scale and evolve and do a lot of stuff, but the operational cost is higher, okay? We scale parts from the microservices, and that's the most important thing. So how do we avoid a distributed monolith? Okay, when we have real bounded context, stable contracts, avoid circular dependencies, and we avoid long call change. Okay, how do we avoid distributed monolith with real bounded context? Again, here is where the business rules and the capabilities of what we want, what the business want, is very, very important. Okay. Another question: how we prevent cascading failures between microservices? With short and explicit timeouts. HTTP clients, for example, Refit via HTTP client factory, must be configured with timeouts. Okay. B. Retries with criteria and backoff. Retry only for transient failures, 500 errors, timeouts, and network issues. Okay. Circuit breaker. Stop hammering a service that is down. D. Bulkheads and concurrency limits. We need to isolate the resources so one slow downstream doesn't consume all the threads or connections. And E. Fail fast with consistency errors. Okay? When something fails, we have to respond quickly and consistently. If coordination is needed, we have to evaluate a sync event or a controlled aggregator. Okay? As a final takeaway, monolith optimize simplicity. If we need something fast, simple, granular, and that we needed to ship it as app, we go for a monolith. Okay? When we have clear boundaries of what the business want, what the pieces of the product are, if it's all aligned, there we have real boundary context around the business. Okay, so microservices optimize the independent ownership and deploy. With microservices, we can optimize the pieces of the well-defined product that we want to build with our system. Okay, but microservices, we have to keep this in mind. Microservices demand resiliency, observability, strong boundaries, and the mature platform operations. So to do great microservices, we need to have a good architectural DevOps team to help us with CI, CD, with the deploys, with all of that, with exposure, with the PIM if we cannot touch it. We need the business to be ready to know what they want, the pieces of the product that our system is going to be built, and so on. So hope this helped, and if you like the video and it helped you, give a thumbs up, subscribe, and have a great day. Bye bye.